Hello, can you hear me?
Yes. Okay, so the lecturer is already with us, so we will start in a couple minutes. Thank you for your patience.
Can you hear me, guys?
Yes, already checked. Can you hear us?
Okay, great. I'm very sorry that I'm late. It was a very important meeting with our rector. So, let's start. Here is my presentation. Okay. Okay, today we'll talk about the economics of climate change and the concept of sustainable development. This connection is important just because, as a rule, when we talk about sustainable development, we mean the environmental side of this issue. But here I would like to show you that economics is at the heart of this story. And the solution to the problem of climate change is also more related to economic and, let's say, moral problem of humanity, rather than ecological or technical aspects. So we have two lectures today, and I don't remember, 2 weeks later. Today we will focus on theoretical aspects, and in the second one we will talk about specific technologies and measures of decreasing carbon intensity of energy sector. Okay, considering that the economics of climate change is a wide scientific field, as well as sustainable development, we will go through the key aspects of this issue and we'll try to see, let's say, the depth of this direction. To do that, we will discuss 4 key topics. First of all, I will show you why sustainable development is largely an economic concept, where the ideas underlying it came from, and what was the chronology of events which lead us to its present state. Next, we will talk about the theory of technogenic global warming, our role in this process, role of humanity, and potential consequences for the humanity. Then we will have to dive into the theoretical issues of economics related to the production and consumption of goods, but this is necessary to understand the economic side of greenhouse gases emission. And in conclusion, we will briefly discuss integrated assessment models and how the cost of greenhouse gas emissions is determined. These models are the main tools of economics of climate change. They allow to predict what will happen in 50 or maybe 100 years or more. Of course, the reliability of such calculations is questionable, but it is interesting because it is based on the interaction of several models from different fields of science. For example, geology, economic models, atmosphere models, environmental models, and other different models. Let's start with the simplest part. The concept of sustainable development is based on the idea of finding a balance between the economy, ecology, and society till 2030. We have 17 large-scale goals of sustainable development, like improvement of the quality of education, fight against poverty, take care about our planet, etc., etc., etc. These goals consist of 169 targets, which are expressed in 230 specific indicators. So it is a very big multi-layer system of development directions. And it is something like a moral compass for the whole humanity. Then, why it is a problem? It is a problem just because this system is based on contradiction. We as a society want cheap and of course high quality products and services, and better for free. Business, on the contrary, want to earn as much as possible from us. For example, by raising prices for their products or services. From the point of view of ecology, it would be better if we didn't exist on our planet at all. We have three sides with absolutely different interests. And these sides should be satisfied by one set of actions. And it is something like a trade-off, very difficult trade-off. This is a huge challenge for us, for you, and for future generations. Each generation have to make a right choice. At this moment, the most powerful part are baby boomers and Generation X. But a few years later, this power will come to you, and somehow we need to ensure such a development that will allow humanity to meet its needs for hundreds of years and have at least the same quality of life as we have now. So by future generations, we mean not you, but at least the children of your children. And this is a very long-term concept. Okay, that was the future. Let's go to the past. I have left this quote in full because it perfectly describes the entire history of the emergence of sustainable development ideas. The beginning can be considered from 400 years before Common Era. Aristotle proposed the idea that households should be not only consumers but also producers. In other words, they should partially satisfy their economic needs, satisfied by themselves. What does it mean? It means that households should rationally use their resources. And this can be considered as a starting point for the ideas of sustainable development. and this is absolutely economic issue. 400 years before Common Era, no one thought about ecology. Environmental aspects of sustainable development was born only near 17th century in the field of rational use of forests. Let's go to recent centuries. Firstly, it is necessary to note the start of data collection in 1958. This is the beginning of a detailed analysis of the carbon content in the Earth's atmosphere. And it was these data that years later caused a panic about the human influence on the climate. And this and in the following slides, I have listed some classical publications related to the topic of this lecture. I will not dwell on each of them, but I highly recommend you to at least quickly scroll them. For example, Carson's studies are connected with the fundamental change in understanding of human impact on the environment. Hardin's study explains why it is extremely difficult to cut emissions of greenhouse gases. So these fundamental studies could be useful for you just to see the whole picture of this really wide area and to understand how environmental side of this of sustainable development was developed. In 1962, two extremely important events in the history of sustainable development took place. The first is the preparation of the report of the Club of Rome. The Club of Rome was founded in 1968 at Accademia di Lincia. It is Rome University, Rome Academy. It consists of 100 full members selected from current and former heads of state and government, high-level politicians, scientists, economists, etc., etc., etc. So it is extremely powerful body with really wide competencies and knowledge. There are a lot of interesting and relevant things in their report, even for present days. But the key conclusion that concerns us is shown on this slide. And this is an exclusively economic issue of production and consumption of energy, economic resources. Again, economic issue, not ecological. In simple words, it means that we consume too much limited resources, and this is a problem. And it will be a problem of future generations. The second important event is the first United Nations Conference, which was devoted to environmental issues. This is important because before that, people had never discussed ecology at so high level. Soon after, the first oil crisis broke out. The reason of that was the support of Israel by United States. As a result, Arab countries banned oil export to the United States. This caused unrest in the US because it became clear that the country could become a hostage of high energy prices. After that, scientists became interested in the exploration of the influence of natural resources on the economic development. And a year later, Nobel Prize winner William Nordhaus published a study in which he analyzed 3 key channels of the influence of natural resources on our society: availability, price, and environmental damage. We will return to this work a little closer to the end of the lecture and briefly discuss each channel. Well, of course, I should also mention Brundtland's report, Our Common Future. It was prepared by World Commission on Environment and Development. In 2 words, this report is about the necessity of changes in almost all fields of our life, starting from our lifestyle. And this report was one of the main reasons why sustainable development is associated with environmental issues. Then, in 1992, a significant United Nations conference was held in Rio, which many consider to be the starting point for the concept of sustainable development. But I hope that you will not think so anymore. The history of this concept starts significantly earlier. By the way, no one international regulatory measure or event cannot be the starting point for any issues, because there is a great lag between research studies, social attention, and political actions. And political actions, as a rule, are the last in this set of things. After that, quite a lot of intergovernmental agreements appeared on various issues related to the sustainable development. On this slide, I showed the key ones from the point of view of climate problems, but of course there were much more of them, especially if we consider national statements, programs and strategies. Okay, the story is sorted out. What do we have in present? Firstly, I just want to emphasize the difference between two terms that usually confuse lay people. Climate is a probability distribution, and weather is a sample from this distribution. For example, if it snows today, it doesn't characterize the climate as a whole. It's just an event that happened with some probability. We can't say that there is no global warming because it is cold today, and vice versa. So, in other words, weather is a local characteristic of what you see outside the window. Let's very quickly go over what is global warming. We have an atmosphere on our planet in which natural and man-made greenhouse gases are accumulated. You can imagine a greenhouse. These gases act as a roof and retain heat on our planet. So, with increasing the amount of these gases in the atmosphere, our roof become thicker and much heat stay inside the atmosphere, and it is called greenhouse effect. There are a lot of greenhouse gases. As a rule, we are talking about CO2, carbon dioxide, or about CO2 equivalent. Why it is so? Why we need CO2 equivalent? Well, first of all, why we use CO2 as a primary indicator of greenhouse gas emissions? This is so because CO2 emissions is we have the largest amount of CO2 emissions in comparison with other gases, and CO2 is the sum of all other parts of our greenhouse gases emissions recalculated, taking into account the global warming potential index. You can Google what is it, but in brief, this index shows how dangerous the gas is for global warming process compared to CO2, or it would be better to say how much heat it can retain in the atmosphere. Fortunately, about 75% of emissions are from CO2. F gases, which are shown at the bottom, in the right part at the bottom of this slide, have the highest global warming potential, but they occupy only a small share of several percent. They occupy only several percent of total emissions. However, don't forget that their influence is still very, very dangerous for us and for climate process. What is also important is a methane emission, CH4. On the previous slide, I have showed you that its global warming index is 21. So it means that methane emissions, despite lower total amount, could be much more important for climate change process rather than CO2, because it occupies 17%, but it is 21 times much more important for this process in comparison with carbon dioxide. We also see here that around 70% of all emissions come from the energy sector. That is why there is so much attention to it within the framework of the concept of sustainable development. We believe that over the past 100 years, humanity caused a strong influence on the concentration of CO2 in the atmosphere. As a result, current levels of concentration have probably not been observed for about 800 years, according to this graph. Its present concentration is about 410 parts per million. It sounds not too much, but its impact probably great. Here is the rate of increase in the concentration of CO2. And we see here a drastic increase in the average temperature on the planet since the middle of the 20th century. And there are no other explanations of these graphs except human activities. Actually, it would be better to say that there is no other explanation at this moment. Who knows? Maybe we will find another reasons in the coming years. Actually, I hope so. I hope that we'll find it. Regardless of this, the consequences of global warming are predicted to be extremely terrible. Just look at this slide. Climate change will affect almost all life on our planet. What is also important for us, if we are not talking about extinction, is that all these changes will have an economic impact. And I mean not only financial aspects, but also relationships between countries, companies, households, people. We will have to adapt to these changes, change our lifestyle. Just imagine only the influence of global fires. And this is only one aspect of this issue. In addition, some countries will suffer much more because of these processes. Mostly developing equatorial countries, because their climate is already extremely hot. Further raising of temperature will make these regions extreme for living. The global injustice lies in the fact that the poorest countries will suffer the most. Countries which are not connected with the emissions that have been made over the past 100 years. Moreover, countries affected by rising sea levels will also suffer from these consequences. A rising level of sea is recognized as one of the most serious problems of the coming years, because we will need to adopt our logistic and save our cities from this process, and it's extremely expensive, and it is difficult to model this process, reliable models. And what about financial side? Here are some results from so-called Stern review. This is one of the most, let's say, well-known works in the field of economics of climate change. Despite very serious criticism, about his calculations, the contribution to the development of these directions cannot be denied. It is extremely comprehensive and deep report. So, according to Stern, the lack of climate measures will cost about 20% of annual gross domestic product. Just imagine that your salary was sharply reduced by 20%. This is almost the same. At the same time, we can lose only 1% in case of immediate activity. So everything depends on the speed of solutions. 19% difference is explained by the fact that the damage from the emissions of 1 ton of CO2 was estimated at $85. But to prevent these emissions, we have technologies which cost around $25 per ton. So the difference is really huge. But unfortunately, I can't agree with Stern in this assessment. The set of such cheap measures is extremely limited. And in the next lecture, we will look at approximate prices of them. They are far from $25 per ton. You will see that. Moreover, some kind of measures cost around $2,000 per ton. Okay, now try to forget everything that I have told you about our responsibility for climate change. This slide is about uncertainty. The graph at the top on the left side is the basis of the climate measures that we see today. It's the basis of everything that I have told you during the previous slides. This is so-called man's hockey stick. It shows that present rise of temperature is a unique situation, and there were no similar periods during the last 1,000 years. The graph below shows the position of another climatologist, Professor Tim Ball. As you see, there were periods with much more rapid and serious changes in temperature during the last 1,000 years. There are two interesting things about these graphs. Firstly, their data differ significantly. They show absolutely different pictures. Secondly, Tim sued Michael, Professor Mann, for falsifying his data. Just think, Mann's graph has been accepted by the entire scientific community, but the Supreme Court of British Columbia sided with Professor Ball. The reason was extremely simple. Professor Mann declined to provide the input data of his analysis. I would not like to tell you how to create this, but there are a lot of such strange things in the climate story. Maybe this story about our role in this process is not so obvious as we believe. To read something about that, you can check World Climate Declaration. This is let's say this is a document of opposition of Professor Mann's theory, opposition of technogenic climate change theory. Nevertheless, the official point of view is that we are responsible for climate change. So we need to understand the specifics of this process. First of all, pay attention. No one ever talks about stopping climate change or reversing it. It is always about slowing down the pace of these changes. And this, secondly, this requires the participation of the whole world, because despite geographical differences, everyone will suffer, and we need a contribution of all countries and all companies. For example, all Africa can reduce their emissions, but without China it will be useless. Because if we compare their carbon intensity, we will see that China emits much more carbon dioxide and other greenhouse gases. And thirdly, at the same time, it is difficult for us to say who will suffer and to what extent, since everything related to climate change is extremely long-term and uncertain, unfortunately, and we can't do anything with that. So, let's go back to Nordhaus' study. Three key problems, three main channels of natural resources influence on our economy: availability, prices, and environment. Let's start with availability. Nordhaus showed that there are no specific problems with this, but only if we judged on a global scale. But here we have a very, very important limitation. We believe that resources are evenly distributed. In other words, we eliminate all possible transportation costs and political conflicts. In fact, modern data show a similar situation. For example, at current prices and consumption levels, we have enough oil for at least 50 years or more. You even cannot think about coal or natural gas. Their reserves are much larger. But of course, in practice, we have a political influence, which create barriers for fair distribution of natural resources among the whole humanity and among different countries. And these barriers, unfortunately, are one of the main reasons for many wars on our planet in the last centuries. Regarding the price, he also concluded that price is not a critical factor. In fact, if we ensure that the salaries are growing faster, and it is highly possible that the relative cost of fossil energy in the future will be even lower than at the time of the assessment. In fact, we have already seen such periods in the history of the United States when our salary rise much faster than the price for energy resources. Here is a graph of changes in oil price. All the peaks here are connected with some political events. Even with that in mind, if you calculate the average annual growth rate, you will not get huge values. Most likely that they will be below 5% per year, unless you intentionally take very specific point on the chart. For example, in the beginning and at the top of the crisis. The third problem is a real problem, according to Nordhaus. He predicted that by 2030 we will reach 487 parts per million concentration of CO2 in the atmosphere, and we are already close enough to this value. On this slide, you see the elements of carbon budget system. We have several sources and several sinks of carbon. Let's say that there is a continuous exchange between left and right parts. By the way, we can also add forest to the right part, but it is a bit questionable element, because in case of fires, all stored CO2 will be released to the atmosphere. The crux of the problem is that our natural CO2 storage facilities may be not enough large to contain all the carbon dioxide emitted in the atmosphere. Accordingly, this is a movement towards an ecological catastrophe. This is a great problem for us. We don't know, for example, first of all, how to capture emitted CO2, and secondly, where to store this CO2. So, what was a contribution of Nordhaus which allowed him to receive the Nobel Prize? He built numerical models which describe the interaction of climate processes and integrate them into long-term macroeconomic analysis in so-called integrated assessment models. In simple words, he explained and connected mathematical description of three mentioned channels in a single model. So, let's start the movement towards these models and try to find the solution for the problem of technogenic climate change. First of all, you need to understand what means economy. It is not simple money calculation. It's a relationship between people, organization, countries, etc., 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 between different parties. And it is expressed in flow of different resources, not only money. It can be everything: water, gold, iron, steel, personal computers, mobile telephones, everything. The most common definition of economics sounds like it is a discipline about rational choice. And to make this choice, rational choice, we have classical supply and demand curves. They can also be drawn as a simple lines. So what does it mean? The higher the price of a product, the less we are willing to buy it. But with the price increase, there are more and more and more manufacturers which would like to sell it for us. And the inverse relationship. In this manner, the market is looking for a state of balance, state of equilibrium. It means that we have the same desires of producers and consumers in terms of price and volume of products in our market. If we have too much products, we need to store them. If we have not enough products, our customers will be satisfied. It will be bad for our customers. Okay, there are myriads of products and services. One of the important ways to separate them is presented here. We have two characteristics which divide goods into four categories: privates, common pool, club, and public goods. With many of them we have no problem. For example, it is relatively easy to agree on the price with a street seller. It became a bit more difficult, but still possible, to explain how much should cost cable television. What is more difficult is to determine the price of public transport. I mean, its value in financial terms, how much it should cost for users. And the most unpleasant in our situation are public goods. The problem arises because they are free and they cannot be taken away from us. They cannot be refused because they are non-excludable and non-frivolous at the same time. They just exist, but we can just create a market for them. What is possible to do? Public goods are associated with externalities. When we use a public good and it affects someone else, it is called externality. If such effects are undesired, as in the case of pollution, they are called negative externalities. If they are desired, then it is positive externalities. And just an example, imagine a group of citizens which get together to clean up a public park. Who will benefit from that? I think that almost all visitors of this park, whether or not they were part of this cleaning group, they will benefit from that. And this is a positive externality. Regarding negative example, you can imagine an enterprise which pollutes the water. People who are living near this enterprise will suffer from that because they don't have another source of water. And this is an example of negative externality. The externality of climate change is extremely simple and extremely difficult at the same time. We have already understood many years ago how it is possible to solve the problem of greenhouse gas emissions, at least theoretically. It is enough to eliminate the difference between the market value of environmental dirty ways of resource use and their social cost. So the difference between social cost and market cost. Social cost is a kind of monetary equivalent of total effects which are caused by products or services. As you see on this graph, it is a sum of market cost and the cost of emissions. It is an example of negative externality. We know how to find market costs, but the second item is a great problem. It is extremely difficult to determine the cost of emissions. There are two approaches to solve this problem. The first one is cause approach. The essence is very simple. We need to create a market for this public good. If we can create a market, determine the conditions, and give to our participants the opportunity to bargain, then sooner or later the market will find the balance. And the price in this point will be equal to social price. So social price will be equal to an equilibrium price. However, the problem here is quite obvious. It is very difficult to create a market, for example, for clean air or air. Moreover, to operate properly, this mechanism should be global, and this market should be global. In some science fiction films, you can find such solutions. The interesting thing about this approach is that we can achieve market equilibrium without government regulation, and it is really cool. But the perspective of buying air for ourselves and for our children is actually a bit scary. So the second approach involves the introduction of polluting emissions of taxes, which will cover the difference between the market price and social costs. Everything is wonderful in this approach. By the way, it is called Pigovian approach, and this tax is a Pigovian tax. So everything is great except determining the amount of this Pigovian tax, especially in the case of greenhouse gas emissions. Indeed, how to determine the damage from the emission of 1 ton of CO2, how to determine its effect on a a particular group of people at a certain point in time. In this graph, a deadweight loss is a cost to society created by market inefficiency, which occurs when supply and demand are out of equilibrium. It is something like a measure of inefficient allocation of resources. So we need the state of balance to remove these losses. And these losses are, let's say, it is a sum of losses of consumers and producers. So it is a total losses of the humanity. Despite the difficulties, scientists have come up with several solutions to this problem, which made it possible to calculate the social cost of carbon, SCC. As you can see on this slide, this is a social cost of carbon dioxide. It is a quantitative assessment of all costs and benefits from emissions of 1 ton of CO2. I mean, all effects, not only today's consequences, but also the coming 100 years consequences. So, social cost of carbon is actively used in many countries for the development of various climate policy measures. So, to calculate social cost of carbon, it is important for us to know how to assess the benefits and costs of climate change. There are 3 traditional approaches for that. The first one assumes that we ask the opinion of experts in various fields about the possible consequences. After that, we conduct statistical and financial assessment of their answers. That's all. Expert approach. The second method is related to the analysis of differences in the development of regions with different climates, but with a similar structure of the economy. The essence of the second approach is to compare objects with their analogues, which exist in climatic conditions close to the predicted. Just an example, if there are 2 pieces of land that differ only in the temperature, the difference in the price of these lands will show the gain or maybe loss of the owner after increasing of the temperature. This approach is simple and clear, but it doesn't reflect the possibility of adaptation. To take it into account, it is possible to include the possibility of changing the type of land, for example, the type of land use, in response to climate change. The third method, it is associated with a detailed assessment of forecasts in individual areas. This is somewhat similar to the assessment of insurance companies. By the way, these companies have extremely developed methods and very detailed. An interesting work on the analysis of these methods was published in 2017. Authors analyzed the existing approaches and came to the conclusion that the impact of global warming by 3 degrees will lead to decrease of global gross domestic products by 2%. These numbers are shown in this slide, but look at mistake. Look at error of this calculation. Some countries will even benefit from global warming. It is fair for increase for 3 degrees temperature. but with the warming up to 6 degrees, there will be no winners. And this is our long-term future, very uncertain estimation, but we have such calculations and we have such forecasts. Today, the most advanced method to perform such calculations and to calculate social cost of carbon is the use of integrated assessment models. Here is a schematic description of dynamic integrated climate economy model, DICE model. It is one of the most respectful and commonly used model. You can also find two other models, but they are not, let's say, not so popular. As I said at the beginning, this model allows us to combine the economy, geochemical carbon cycle, and social factors. If you would like to see technical details of this model, you can visit a website which is shown at the bottom. Objective function of this model is social welfare, which is a relatively difficult economic concept. It is difficult because, in fact, we don't know how to properly assess it. We don't know a single measure of welfare. Despite this, economists very like this term and this measure and use it widely in many kinds of assessments. The simplest way is to think about it as about consumption. So, in DICE model, consumption is connected with production. Production is connected with emissions, and social cost of carbon is determined according to the formula on this slide. With increasing carbon emissions, we are losing our production and consequently consumption, which is an indicator of our welfare. So emissions affect our life through the consumption and through the production of goods. What you also need to know is that there are hundreds of carbon cost estimates. They ranging from $17 to several $1,000 per ton of CO2 emissions. This slide shows the material from another Nordhaus article, which provides some estimates for the most commonly used models. What is important here? First of all, social cost of carbon varies for different countries, depending on a number of characteristics like total emissions. For example, you can see in the right table that China should pay the highest price due to the largest share of global emissions. Second important thing, social cost differs in different models. Just look at the bottom table. Even DICE models of different years have different results. The good question is why we have so many differences. And the answer is relatively simple. Calibration of models and different assumptions. And this is the key point of criticism, which is mentioned in a World Climate Declaration. I have told you about it in the middle of this lecture, in the slide with uncertainty and two graphs of Professor Mann and Professor Ball. Here is one of the most important factors for such long-term assessment. It's a discount rate. Any results of calculation in integrated assessment models are connected with how society estimates costs and benefits related to different points in time. In general, it is logical that for society, the utility of consumption today is higher than the utility of consumption tomorrow. Simple example, $1 in the next year will be cheaper than today. Discount rate allows to make our long-term calculation with taking into account this difference. And even a small change in the discount rate will have a very significant impact on the results of our calculations in the centennial period. But you need to understand that discounting the utility of welfare is more an ethical rather than economic or financial concept. Consequently, when it comes to analyzing climate change policy, we are far from a consensus what value to choose for the discounting. And there are also no justification against a zero rate. If we take it equal to zero, it means that the meaning of all generations is equal. Stern proposed to use 0.1%, which is equal to a risk of extinction of humanity per century. Nordhaus proposed market approach, 1.5%. But in present economic condition, it seems not to market. Nowadays, I suppose that we have to choose about 3, maybe 4, maybe 5%. But where is the truth is a big question. I hope we will find the truth in the coming years, because the heat is coming and we have to do something with climate change processes. We have to adapt our lifestyle, our enterprises, our industries to these changes. And I believe that it is enough for today for you. During our next lecture, we will discuss more specific things connected with technologies and policies, connected with their prices. And now, if you have any questions, I will be glad to answer them. If no, you can write me by email. I will also be very glad. So, thank you for your attention. If you have any questions, you can write in the chat. Any questions?
Thanks, Professor, for this lecture, and we will see you, everyone, on next Monday, right? That will be April 24th. So the links, I hope this time the links will be delivered to me on Friday, and I will get them to you as soon as possible. Lecture materials will be provided by Professor Svetkov to me, and I will send it to the cloud storage that we shared with you. So, yep, thanks everyone for participating in this lecture, and we'll see you next time. Bye, everyone.